Hello guys, today in this video I will help you to have a thoroughly revision of the topic, that is matrix. Okay, so matrix is basically taught in unit 1 of engineering mathematics. Okay, although we study it in 11th also, but still we do forget some concepts. Okay, so we will be having a revision of it, and yeah, one thing more, that the video or the concept explained in this video are college level based. Okay, so don't think that after doing this video or after like doing these concepts you will be able to clear some gate questions. Okay, yeah, so it's just for college level exams. So we're starting matrices. Okay, so well, we already know addition, subtraction, multiplication. Okay, in case of matrix, yeah, multiplication is quite little bit of complex. Okay, so I will explain that too. Okay, let's say having a brief about addition, subtraction of matrix also. Let's say if you have a matrix called 1 2 2 4. Okay, plus let's say 3 4 5 6. It is matrix A and it is matrix B. Okay, so A plus A will be nothing but simply we will just add these values. Okay, we will add entries corresponding to same I and J. Okay, so like we will add 1 with 3, so it will be 1 plus 3 4, 2 plus 4, okay, it will be let's say 6, and again 2 plus 5 7, and this 4 plus 6 10. Radically? Okay, so this will be 10. So in this way, if we were doing A minus B, okay, so it will be nothing but 1 minus 3, that will be minus 2, 2 minus 4, minus again minus 2, 2 minus 5, minus 3, and so on, like 4, and it will be minus 6. Okay, so it's quite easy. Now we will be slowly going over the main topics that we need to discuss in this video. Okay, so now, okay, let's discuss about multiplication. Consider we have a matrix called A is equal to, let's start with the first 2 by 2. Okay, again 2 4 and 6 3. Okay, and B is equal to, let's say anything 1 5 13 7. Okay, for simple calculation let's make it 3. Okay, so if we have to find A into B, I mean if we have to find AB, it will be A here 2 4 6 3 and B 1 3 5 7. Okay, so the method to multiply these is take this column and multiply it with the next, multiply it with the row of next matrix. Okay, so first you will be considering this column and this row. Okay, now let's write new matrix. It will be 2 into 1, 2 into 1, 2 into 1 plus 4 into 5 plus 4, okay, multiplying 4 into 5. Okay, and now again writing values for this position. For this position we will be considering this row, this row and this column. Okay, like it will be 2 into 3, 4 into 7, so plus 4 into 7. Okay, and now writing for this position, see, we can generalize this also. Okay, we can generalize this also. Let's have a look how. Well, it is nothing but it is A11. Okay, it is A12, it is 21 and A22. Okay, so basically what we are doing is we are making AB. Basically we are making AB11 is equal to A11 multiply with B11. Okay, so A11 B1 is equal to A11 multiply with B11. Okay, and now A12 multiplying with B12 plus A12 multiplying with B12. Okay, so again we can think it like this also, that for getting values at position I equal to 1, j equal to 1 in AB matrix, what we are doing is we are basically first considering a row with I is equal to 1 and we are multiplying it thoroughly with the column I is equal to 1. Okay, like column j is equal to 1 with another matrix. I hope it is clear. If not, then don't worry, I will explain, I will show how to do this. Okay, now for considering this, for writing a new value in AB matrix, it will be 6 into 1 plus 3 into 5. Okay, so it will be 6 into 1 plus 3 into 5 plus 3 into 5. And for this position again we will be multiplying this row with this column, so it will be nothing but 6 into 3 plus 3 into 7, and we can, like, it's normal calculation now. Okay, still if you have any, if you don't get, no worry, I will show you another example also. Let's take another matrix. A is equal to 1 3 1 2. Okay, and B is equal to 7 6 5 4. We have to find AB is equal to, so AB will be, this implies that AB is equal to 1 3 1 2 7 6 5 4. Okay, AB will be 1 3 1 2 into 7 6 5 4. So now for calculation, at this position, that is AB11, it will be, for writing values at A11, we will be considering row 1 of the A matrix, okay, and column 1 of another, that is B matrix. So now we will be writing 1.7 plus 3.5. Okay, and for position at A12, we will be again multiplying this row with that column. Okay, so now in place of this, we will be considering this column. So again it will be now 1 into 6 into 1 plus 3 into 4 3 into 4. Okay, So now for A12, we will be multiplying this row with this column. Okay, so it will be like 1 into 6 plus 3 into 4. Yeah, and now just give a try for writing this position, that is AB21 and AB22. Okay, so just pause the video and try to write on yourself. I hope you have tried on your own. Okay, because be honest with you, if you really want to develop yourself in terms of like whether academic or like anything, be honest with you, at least with you. Okay, so it will be again 1 into 7 plus 2 into 5 into 5, 1 into 6 plus 2 into 4. Okay, so and yeah, it is not a decimal between 1 and 7, it is a dot. Dot means to multiply them. Okay, so like it will be, so it will be 1 into 7 is 7 plus 15, 6 plus 12. Okay, so now it's only calculation. So your answer will be, let's write it here. Answer will be 7 plus 35, I mean 7 plus 15. And be attentive with your calculation, even a silly mistake can cost you marks. 15 plus 25, 6 plus 12, 18, 10 plus 17, 14. Okay, so it will be matrix that we get after multiplying A and B. So now we will be heading over towards easy concept, I mean towards an easy problem. Okay, that is for 3 by 3 matrix. A is equal to 1, 2, 1, 1, 4, 3, 2, 6, 0, and B is equal to 2, 3, 5. Well, I'm taking even values just for calculation. Question in values, actual values in question can be anything. Okay, and like process will remain the same, like how to approach the solution. And then 3, 5, let's say 1, 0, 2, and let's say 0. Keep the same entries to be 0 for easy calculations. Okay, so again for matrix AB, what we will be doing is we will be considering, okay. Think on your own, try to think on your own, think on your own. See, the process is still the same, just what we have done is we have increased a dimension. Okay, like it was 2 cross 3, now it is 3 cross 3. Okay, yeah, it was 2 cross 2, now it is 3 cross 3. Just try to think on your own. I'm giving you a hint. Still, we will take a row at a time and will multiply it with a corresponding column of another matrix. Okay, I'm repeating again. We will take a row at a time and corresponding column of another matrix. Okay, like for this row we will be multiplying it with this for this position. Now try to think on your own. So pause the video and try yourself. Okay, so for AB, so AB is equal to, it will be again, we will be taking this and multiplying it with, so it will be 1 into 2. Okay, like 1 into 2 plus 2 into 3 plus 1 into 0 into 0. Okay, now coming to this position, it is AB 1 2. Okay, AB 2 1, AB 2 1, I equal to 2 and J equal to 1. This is I, this is J, and this is I. Okay, so for this column, complete column, J will be 1, J equal to 2, J equal to 3, I equal to 1, I equal to 3. Okay, yeah. So now 1 4 3. Now coming to this position, it will be 1 into 2 multiplying now this with this 4 plus 3 into 0. What the fuck? Yeah, it's okay. 3 into 0. Okay, now again taking, let's rub it. One, two, one. Okay, so now taking this row and this column, so it will be 2 into 2 plus 6 into 3 plus 0 into 0. Again for this position we will be considering this row with this column. Okay, okay, so writing complete process, and don't give up in between. It's obvious that it's a 3 cross 3 matrix, so multiplication will take some time and your efforts too. Okay, so it will be 1 into 3 3, 2 into 5 plus 1 into 2, 1 into 3 4 into 3 3 into 2. It will be 5, my fault. Okay, 2 into 3 6 into 5 and 0 into 2, 0 into 2. Okay, so now for this column, writing the values in column, we will be, what we will be doing is we will be keeping, like we will be multiplying this matrix by this column. Okay, so now it will be 1 into 5 plus 2 into 1 plus 1 into 0, 1 into 4 plus 4 into, it will be 5, my fault, 1 into 5 plus 4 into 1 plus 3 into 0. See, for faster calculation, wherever you see a 0 is element is an entry in the matrix. Okay, you can like skip this if you are comfortable with that. So it will lessen your steps. Like see, I have written here 1 into 0, 3 into 0, 0 into 0. Okay, like here it is clearly visible that whenever we will multiply 1 with a 0, it will give us just 0. Okay, it won't affect our answer. So we can skip this part if you are comfortable. Okay, if you are comfortable with it. Else I don't recommend. So 1 into 5, okay. Now we will be multiplying this row with this column. So it will be 2 into 5 plus 6 into 1 plus 0 into 0. Now just simple calculation, nothing more. Okay, 2 into 3, 6 plus 2, 8. And then 4 there 12, 12 into 14, 4 and 18, 22. Yeah, that's it. And that is 3 plus 10 into 12. 3, 15, 18, 18 and 6, 24, 5, 20, 5, 4 are 20, 20 and 3, 23, 23 and 6, it will be 29, 6, 30, 36, it will be 36. Okay, so 5, 1 into 5, it is 2 basically. Even I'm not getting what I have written. Okay, so 5 plus 2, it will be 7. 7. Again, we want to calculate that. So 5 plus 1 into 5, 4 into 1. Okay, 5, 4, 9, 10 and 6, 16. Okay, so the final matrix, that is after multiplication, what we are getting is 8, 12, 7, 14, 29, 36 and 16. Okay, into B. So this is the final matrix that we are getting. Okay, I hope the concept is clear. Okay, so now we will be heading over towards some main topics that examiners commonly ask in examiners commonly ask. Okay. Okay, so now we will be starting with the main part, that is examiner commonly asked in exams. Okay, in college level exams. So first we will have a brief overview of what all topics we are going to cover. Okay, so diagonal matrix. Diagonal matrix is as the name sounds, okay, something related to diagonal values. So it will be d1, d2, d3. d1, d2, d3 refers to any diagonal value, okay, in the matrix 0, 0, 0. So as we can see, a diagonal matrix is a matrix in which entities other than diagonal elements are 0. Okay, are 0. Or we can rephrase this in this way too, that all elements of a diagonal matrix are 0 except diagonal entries. Okay, so now coming to next, it is identity matrix. Identity matrix, as you all know, identity matrix is 0, 0, 0 and 0. Okay, yeah, so again identity matrix and diagonal matrix are sort of similar as it seems to be. The only difference is that in case of identity matrix, diagonal values of a diagonal matrices are equal and equal to 1. Okay, so now scalar matrix. Scalar is again sort of similar to diagonal, but the difference is all entities, it's all values at a diagonal places are equal. Okay, are equal. Now we can see a diagonal matrix is a matrix in which entries other than these diagonal elements are 0. Okay, are 0. And identity matrix is a matrix in which all diagonal elements are equal to 1 and others are 0. Other values are 0. Okay, and in case of scalar matrix, every diagonal element is same. Okay, or we can say every diagonal value of a scalar matrix is same and rest are 0. Or we can say this too, that okay, let's see it in a question form. Like, okay, what is the condition required for scalar matrix is equal to diagonal matrix? Try to think and try to answer it. It's a very easy. You have the representation of a diagonal element also, diagonal matrix also, and scalar matrix also. Okay, so write down the condition, or you can mention the condition to convert this diagonal element into scalar element. Okay, and no row transformation is required here if you know that concept. If not, then no worries. Just try to think, and if you got the answer, pause the video and mention it in comments. Okay, yeah, so I hope you have tried on your own. If still it's not possible, you can try to write down this way. If it's still not clear to you. Scalar is nothing, d. Okay, 0, 0, 0, 0 and 0. And diagonal is d1, d2, d3, 0, 0, 0, 0, 0 and 0. What we need is, we need both of them matrix to be equal. Okay, we need these matrix to be equal. So see, for a matrix to be equal, for two matrices to be equal, there is corresponding values should be equal. Okay, what I mean is, like, if we have a value of scalar at a11, okay, it is, let's say scalar is a S matrix and diagonal is a D matrix. Okay, so if we have to do S equal to D, what we require is two matrices are said to be equal if their S Ij is equal to D Ij. Okay, I mean whether I equal to 1, J equal to 1, J equal to 3, I equal to 3, anything. For a particular value, for any value of I and J, okay, the entries at Sij and Dij must be equal. Okay, like for an easy example, we can consider it like as 2, 3, 4, 5, 2, 3, 4, 5, Sij, and another matrix 4, 3, 6, 5. It is 5, 5. Okay, see here the value at, let's say it is matrix A and it is matrix B. So the values at A11 is 2 and B1 is 4. So we can say these are not equal. We can clearly see these are not equal. Okay. And now the value at A12 is 3. Again the value at B12 is 3. So these are equal. So this is the criteria that we check while calculating the equality of the matrix. Okay, while checking whether they are equal or not. So now we have found one entry which is not equal into matrix. So we will say A not equal to B. Okay. For equality to hold true, all values corresponding to same I and J must be equal in both the matrices. Okay. So now see at it is S matrix, it is J matrix. At S11 we have D, and at D11 we have D1. If we want to make these equal, make these matrices equal, so it means S11 is equal to D11. Okay, this implies that D is equal to D1. D is equal to D1. Okay, and again S22 is equal to D22. This implies that D is equal to D2. And for S33, writing it here, S33 is equal to D33. This implies that D is equal to D3. Okay, so from here what we get is D is equal to D1 is equal to D2 is equal to D3. This is the condition. This is the condition for a scalar matrix to be equal to diagonal matrix. Okay, or we can rephrase it in this way too, that for a diagonal matrix to be a scalar matrix, all the diagonal entries should be equal. Okay, they should be equal. Okay, so writing it in short way, it will be S is S and it is D. S is equal to D only if D is equal to D1 is equal to D2 is equal to D3. Okay. is an important concept. Okay, and it can be asked in form of MCQs also. Okay, so now we have covered diagonal, we have covered diagonal matrix, identity matrix, and scalar matrix. Okay, so see, I'm not bringing this, you can note down if you want. Okay, I will try to provide you the PPT of this. Okay, like slides of this. Yeah. So now we will be studying about adjoint of a matrix. Okay. Adjoint of matrix. Well, before moving to adjoint of a matrix, you should be clear with what a transpose is. Okay, what a transpose is. So for a transpose, let's say A vector is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, what the word transpose means? Transpose is nothing but we interchange the corresponding row with the corresponding column. Okay, or just say that we interchange corresponding row and column. Like it is column is equal to 1. Okay, so let's call it as C1. It is column is equal to 1. It is column is equal to 2, and this column 3. It is row 1, row 2, and row 3. Row 3. Okay, so now as I have told you, we interchange column and row correspondingly. Okay, so A transpose will be A transpose is equal to, now column 1 will become row 1. Okay, column 1 will become row 1. Writing it here, A to A transpose. How to go from A to A transpose? Column becomes row and row becomes column. Okay, so now new row will be this one, 1, 2, 3, and now column will be 1, 2, 3. Okay, and this column will become row. It will be 1, 4, 7. Sure. Now this is row, so this will become column now. Okay, so 4 is already there. Now 5 and 6. Okay, so now, well, yeah, this is row here. In transpose, it will become column. So 7 will come here. 7 is already there. So now we will write 8 and 9. Okay. So now try to recognize the change in both of these matrices. Okay, try to think. Here it was column 1. Now it is row 1. Okay, so now let's call it as R-1, R-2, R-3, again C-1, C-2, C-3. See, now C1 becomes R-1, 147, 147. C2 becomes R2-, 258, 258. C3 becomes 369, 369, R3-. Okay, so now we have calculated transpose. And do note that the short trick to do this is just interchange these values. See, all diagonal elements are same. 159, 159. Okay, 159, 159. 2 is interchanged with 4. 2, 4. Now it becomes 2 and 4 there. Again 3 and 7. 3, 7. 6 and 8. Okay, so the short trick is take mirror image of the matrix around diagonal, keeping the mirror at a diagonal. Okay, so we can write it in this way too. A transpose is, this is not equality sign first of all. A transpose is mirror image of matrix at diagonal. Okay, so A transpose is mirror image of a matrix when mirror kept at diagonal. Okay, so I hope it's clear now. Okay, so and matrix are of two type. Matrix have of two type also. Okay, like on the basis of transform, on the basis of adjoint of transpose, on the basis of transpose of matrix, we classify every matrix on the base on in two criteria, or we can say in two categories. Okay, like a matrix A on the basis of transpose of matrix, can be classified into two categories, that is symmetric matrix and skew symmetric matrix. Okay, writing them mathematically, symmetric is equal to A transpose, A is equal to negative of A transpose. Okay, so this is a very important thing. You must have seen some questions in your 11th or 12th. Okay, asking to choose whether a given matrix is symmetric matrix or skew symmetric. So if A is equal to A transpose, it will be symmetric, otherwise it will be skew symmetric. Okay, and we can derive one thing also from here. As it is given A is equal to negative of A transpose, it means Aij is equal to negative of Aji. Okay, yeah, and see, for a diagonal element I is equal to j. I hope you are getting it. For a diagonal element I is equal to j. We can verify that too here. It is A11, A22, A33. I equal to 1, j equal to 1, I equal to 2, j equal to 2, I equal to 3, j equal to 3. Okay, so for every diagonal element I is equal to j. So for diagonal element I is equal to j, this implies that, considering diagonal elements, this implies that Aii is equal to negative of Aii. Aii is equal to negative of Aii. So what this states is, for a value present at a diagonal position. Okay, the positive value and the negative value are both equal. I hope you are getting it. It says that the positive of a value is equal to the negative of a value. It means if a number a is given to us, it has any positive value. Okay, so this statement tells that negative of a will be equal to a. Negative of a will be equal to a. Now, can you answer the case when it is possible? So, can you answer the case when it is possible? Try. It's very easy. Okay, see, like it will be taking this, that's it. So it will be twice of ai is equal to 0. Okay, it will be twice of ai is equal to 0. So ai will be 0 by 2. This implies that ai is equal to 0. So ai is equal to 0. So what is ai? ai is diagonal elements. I can be 1, 2, 3, 4 depending upon the order of the matrix. Okay. ai is equal to 0. So from here we can write that. From here we can deduce basically. We can deduce a statement that is for every skew symmetric matrix. Let me write it here clearly. For every skew symmetric matrix all diagonal elements are 0. Okay, why they need to be 0? Because the statement that we derived from this expression holds true only when a number is when a number is equal in both the cases, whether it is positive or negative, and it is clearly understandable that it is possible only in case when the number is 0. Okay, let's say we can't do that 2 is equal to minus 2, like 4 is equal to minus 2, 4, or any random answer. Okay, and we are talking about real numbers only, no complex number concept here. So yeah, or we can say that ai is equal to 0. Note it down if you need, else I'm rubbing it. Okay. So yeah, now finally we are eligible enough to understand what the word adjoint of matrix means. Okay, what is the adjoint of matrix and how to calculate it? So as I have told you in brief, adjoint of A is equal to transpose of cofactor of a matrix. Transpose of cofactor of a matrix. Okay, well, we calculated cofactor earlier also, but now I will explain again in case you are still not comfortable enough with the cofactor. So let's take a matrix. A is equal to 1 2 1 2 1 2 4 0 3. So how we will calculate adjoint of a matrix? How we will calculate adjoint of a matrix is adjoint is represented by this symbol, and order remains the same whether we are doing whether we are transposing, taking the transpose of a matrix, okay, or we are doing, I mean, we are finding adjoint of a matrix, order of the matrix remains the same. So writing it as a journal, it will be, okay, let's say it is A and it is A, okay, so it will be A11, A12, A13, A21, 22, A33, okay. In general it will be like this. Now what we have to do is we have to just find the values of A11, A22 and so on. So A11 is equal to, while calculating A11 we will ignore the row and column that are row equal to 1 and column is equal to 1 in the previous matrix, okay, or we can say that in this also, as the standard books mentioned, that we will delete the corresponding row and column. Here we need to find A11, so the row equal to 1, column equal to 1. So for A11, column 11, we will delete row 1, column 1. Now our focus should be only on these values, okay. Now consider A11 as 1, 2, 0, 3. So we will find determinant of this 2 by 2 matrix. It's very easy, it will be -2, -3, it will be positive 3, again be attentive. A112, now coming to A12, now coming to 12. We will now coming to A12, see, row is 1 and column is 2. It is row and it is column, okay. So row is 1, column is 2. Now we will delete first row, second column, okay. So it is R, okay. So we will do this thing. So now to find A12, as I have already stated, we will delete this row and this column. So now the remaining values is, just pay attention, remaining values is 2, 3, 4, 2. So it will be 2, 3, 4, 2. And determinant of this 2 by 2 matrix will be 6 minus 8 minus 2. In this way we have to find cofactor. It is called cofactor, okay. You have to find cofactor at every corresponding position, and then how to write this is, see, while calculating determinants, like we used to do plus minus plus, okay. Like for a row 1, we will keep it with the same sign, and for row 2 while calculating determinant, okay, like we used to put a minus sign in front of it. In the same way, there is also a standard format for making it easy. What we will do is we will just put negative sign at all the places, again I'm repeating, at all the places in a new matrix that that's sum of row and column number, that sum of row number and column number is odd, okay. See, it is row 1 and column 2, so row 1 plus column 2 is equal to 3, that's odd. that's odd, so negative. At this position, row 1, it is row 2 and column 1, 1 plus 2, 3, negative. At this position, row 3, column 2, 3 plus 2, 5, negative. At this row 2nd and column 3, 3 plus 2, 5, negative. And at rest of the places, we won't change their sign. Okay. So now what we have to do is, it will make the process easy for us. Like we don't need to consider whether to give it a negative sign or positive sign. So once we have done this, now just whatever value you get from by calculating the cofactor, you just have to put them here. Okay, with their sign, no need to change the sign. Let's see, it was 3, so we will put 3 here. Okay, and it was -2, and minus is already there, so minus plus, so it will be +2. In this way, +2. In this way, you have to calculate rest of the values. Okay. So as this video is focused on revision, okay, so let's not indulge into proper calculation, just have a brief overview about the concept. So see, we have covered an Eigen matrix, that is